This is World Oil Deep Dive's special series on oil field electrification technologies, powering today's oil field for tomorrow's energy. Join us as we talk with industry experts about technology ranging from microgrids to e-frac to offshore electrification and more. Now, here's today's episode.
All right, everybody, welcome back. Now we're still here in beautiful Duncan, Oklahoma, at the birthplace of Halliburton, and now we're getting a tour of some of their latest technology. And here with us to explain the control van and what goes on here is Eli Bogle. Eli, welcome to the show.
Thanks for having me on.
Yeah, so tell us about this. I mean, this is some big screens. This controls all of the pumps, all of the pressure that's going on, right?
That's right. So just outside this window here, we've got a Zeus frac fleet rigged up. In a second, we're actually going to control it here and let you pump a little bit with it. I'll kind of start with talking about how things used to be. So 3 years ago, if you went out to a frac site, you would see what we call a pump operator.
Right.
They would be sitting in the corner over there, and they'd be running pumps individually. So if our customer sitting here said, go to 20 barrels a minute, we would have to take a pump, give it a rate set point, 5 barrels a minute, engage the pump, ramp it on, pick another pump, give it a rate set point, engage it, ramp it on.
Oh my goodness.
Rinse and repeat.
Yeah,
exactly.
Yeah, right.
So the first thing we set out to do with Octiv, which is our intelligent fracturing platform, is actually automate those decisions. The way we run pumps has a big impact on our pump life, on our crew efficiency, and on safety. So we want to make sure we do it right every time.
Right.
So 2 years ago, a crew here in Duncan was the first to run this software right here, Octiv. With it, instead of running pumps, we would just type 20 barrels a minute into here, and then Octiv decides what rate set points to give to all those pumps, and it runs the frac fleet as a whole.
Yeah, that's impressive. So you can control everything from here. Like that truck actually right out there is connected to this.
That's exactly right.
Wow, that's impressive. So how long did that take? So you're saying it was 3 years ago, right? 2 years ago that they actually started working
That's
on
right.
this. Now, did you work on some of this too? I understand.
Yes.
Yeah, exactly. So
we started 2 years ago deploying this technology to our crews. By the end of last year, we made it to all of our North America crews.
Wow.
So all of our crews are running this today. You go step into a Halliburton frac van, and this is what you're going to see.
Wow. And I was talking with someone earlier, and they said, Eli, he's a unicorn because you know about the coding part of getting all this to work, right? And you're actually an engineer, right?
That's right. So I started in Kilgore, Texas. I was a frac engineer in the field. Then I worked in our BD organization for a while, and I was really interested in technology and digital. So the last couple of years, I've been working on our digital products and really especially around how we control the frac fleet and then how we connect our customers into the frac fleet data.
That's amazing because I'll tell you, there are very few people that have those two skill sets. So I feel privileged just to be standing here next to you. So now they also said that this is so autonomous now that even I can run it. Is that right?
Absolutely.
No.
Yeah, really.
All right.
I'll show you how this works. So we'll start with this screen down here. This screen on the bottom left, it's our Octiv Connect portal. So this is a customer website. Our customers can log into this from the office, from their home. They can come in and watch their job live. So if the crew's out there pumping with Octiv, the customer can see what's happening, access their data, and even manage the job remotely.
Oh, really?
Yes.
Wow.
So the latest and greatest here is what we call Octiv Auto Frac.
Mm-hmm.
So this is where we take all the intelligence about how we run our pumps and we actually give it to our customers. We give them a key to change how the fleet runs for them. So this screen here is the management portal for full autonomous fracturing. The second our pump operator hits the start button up there, Octiv executes this frac job for the customer.
Oh, so it's all like basically pre-programmed. This is what we want to do.
That's exactly right. So some of these controls here, for example, our customers can set a pressure target. They can configure the rate ramp, how they want the frac pumps to ramp up slowly or ramp up quickly to save time. We've got a screen out detection that's going to help mitigate risk, and our customers can program how the fleet's going to respond to those risks.
Oh, interesting.
And then a few other dials. All of that helps give our customers more consistency so that every time that we start to pump a frac stage, we pump the stage that they want to be pumped.
Now, I'm curious, and I always tell people this. I'm not a technical guy, right? I was talking to smart guys like you is how I learned something about this. But it seems to me like, why would a customer want to program in all these special things? Why wouldn't they just be like, look, man, let the computer decide what's optimal and just do that?
Well, there's a lot. Our customers know their wells better than anybody else. They know the formation, and they're the ones who have all that knowledge around the production side of things to understand what the implications of how we pump a well are.
Ah, okay. Yeah. So this is the numbers they're plugging in. Isn't just something like, hey, I think I'll do, 12,000 PSI. It's tried and true. It comes from jobs.
Exactly.
They know, hey, this rock does best with this pressure.
That's right.
Thing, right?
Everything on this screen, it's all part of the job design. Now, we've had frac job designs for decades. What you're looking at here is just a traditional frac pump schedule. All of these dials, these are the decisions that someone is making at the frac site in real time today. So it might be a day shift engineer or a day shift customer who likes to go fast, and the night shift might like to go slow.
Ah, right. Yeah.
So all those decisions, they're made on the fly today. With Octiv AutoFrac, they get to decide ahead of time what's best for the well and then let that execute on its own.
All right. So now pretend, okay, I work for some company. I'm some company man, and we've already programmed all this stuff. What do I got to do? Can you walk me through it?
Yeah, sure. So, of course, our company men, they're going to be responsible for all the execution of which well we're open to, which stage we're going to next,
Right.
Safety, coordinating of multiple vendors on location. But as soon as that well's open, as soon as, Halliburton has the well and it's time to frack, it's really just a watch and wait and monitor at that point.
Okay. So it's just one button. What do you got to do? What do you got to do?
Yeah.
to
You want to take a seat?
Yeah. Let me try.
We'll get
Let me
going.
try.
So we'll imagine here that we've made our settings here in the Octiv AutoFrac page.
Right.
We've hit the send update button. What that does is it packages up these control settings, pushes them up to the cloud, back down to the frac fleet, and then as soon as we hit the start button up here, it's going to execute.
So it's literally, once all the pre-programming is done, right? That's the tough part. The actual starting of the job is the part. That's the part I can handle.
That's right. So we'll let you run pumps a little bit, and then we'll let you run in auto a little bit. So
nice.
This mouse and keyboard here, they're going to control these two screens up here.
Okay.
I will ask that you don't click anything until I've pointed to it, because this is a live control system, and we're actually hooked up to the frac fleet out there.
So I can blow something up if I do it wrong?
Well, we have a lot of safety precautions in place, but just to be safe, let's go and load in a new plan. So if you'll start on this planning tab right there,
Right.
you can click in there, and then if you'll just click this drop down and load in interval 4.
Okay.
And now you can click the Get Treatment button. So what that's doing, it's pulling in the job plan. All those settings for automation and just the pump schedule itself are now loaded in. So if you come back to the frac console here, I'll give you a quick rundown of all the screens that we're going to use to control the fleet. So this screen here is remote. It's in the customer's office in a web portal. The other 3 screens here are at the well site. It's how we use, so our Halliburton operator is going to control the fleet with all this. The first screen here is our digital red zone. So this is a digital twin of all the high pressure plumbing in the frac site.
Right. Okay.
It gives us a way to have full visibility into that red zone without having to enter. And it also gives us the ability to open and close valves to help, let's say, close a valve so we can pressure test, open a valve to bleed pressure off. So all the valve commands that we do are done through that screen there. Now we're already set up to pump, so we don't need to do anything on that screen. I'll show you the next one here, which is our equipment control screen. This is our spread manager in Octiv. Now we don't have to run pumps like we used to, but we do still manage the spread here. And so this is where we drag and drop our pumps to imitate the rig up outside. It's where we assign the pumps as either clean, dirty, or offline. So in this case, we have 4 pumps outside.
Right.
All of them are assigned as dirty, and they're rigged up, fired up, powered on, ready to go at this point. So you don't have to do anything in there to pump a job.
Wait. What's dirty? What does dirty mean?
Oh, good question. So we supply our pumps with either slurry from a blender, so with sand in it, or just clean fluid. So there's a lot of decisions to be made when you're pumping that split flow, we call it. How much rate do you want to get on the dirty side of the spread or the clean side of the spread?
Yeah.
Before Octiv, our pump operator had to do all that math in their head. They had to make sure we had enough rate on the dirty side, that we wouldn't sand off a blender or sand off a tub. With Octiv, they make the assignments here, and then Octiv decides how much rate each pump gets based on that assignment.
Wow. That's impressive. I mean, all of that, because those calculations take time too, right? I mean, that's all something that now, how long would that have taken before if somebody was manually?
That's a good question. So before Octiv, to execute one frac stage, which is about an hour and a half, 2 hours, it took our pump operator 2,000 clicks or keystrokes.
2,000?
That's right.
Wow.
And it seems silly to talk about clicks or keystrokes. We're not like an e-commerce company, right? We're we're a frac company. But every one of those keystrokes or clicks, it's actually a decision point.
Right.
It's what gear was I going to put a pump in? What's my pressure going to be? Is this pump clean or dirty? Mm-hmm. So all of that now, we've simplified that down. It takes, you'll see here, 50 clicks to pump a frac stage at this point. And with auto frac, we bring that even further down.
Crazy. This is like the future. It's like I'm sitting in some starship somewhere or something.
It feels a bit like a video game. So it's, sometimes you forget that you're actually controlling a fleet out here because it looks just like a computer game. So let's start pumping. Let me make sure that we're good to pump. Good to go. Just a quick safety check that everybody's out of the red zone and we're good to pump.
All right,
let's start pumping. So if you would for me, in that top right corner, if you'll just click that start button, you're gonna get a question: is the red zone ready for high pressure pumping? Yes, it is. We just confirmed. And click yes. All right. So the next thing we're gonna do, we're gonna start a stage as the normal way with Octiv. So we're gonna let you run the pumps for a minute here, and then we'll click it into auto mode. So if you'll start in this box right here where we control our slurry rate, click that up arrow one time. It's gonna give us a rate set point of 5 barrels a minute. Now, you see those two blue toaster messages up there?
Yeah. Equipment manager, load balancing, spread.
And then testing injectivity with that pump. So that injectivity test is a safety check. Anytime we start a pump up from a rate of 0, we want to engage it, pump a little bit of rate, and look at pressure to make sure we're not pumping against a closed valve.
Right, yeah.
If we were to do that and pump against a closed valve, it could create an unsafe condition and an overpressure event. So before Octiv, we had to ask the pump operator to do that manually, to make that analysis and then make the decision whether they could proceed or not.
And now it's just automatic. It just runs the checks, tells you.
Octiv does it for you now. That's exactly right. So you can go a little faster. If you'll click 2 more times, we'll go to 15 barrels a minute. Now what we see here is our rate set point has changed to 15.
Right.
Octiv has given all 4 of these pumps the right rate set point to hit that target there.
So it's distributing, so we're trying to get 15 barrels a minute, so it's distributing it evenly, basically, amongst all the pumps.
That's right.
Yeah.
Now, here's kind of the funny thing. Our pump operator here got a little anxious. Our pump design here says 10 barrels a minute, but we're going 15.
Yeah.
This is where AutoFrac comes in. So our customers asked for 10, but for whatever reason, the person sitting in this chair, they might be controlling the fleet a little bit differently than the engineer really wants to. If you would for me, if you'll click on this little operator icon, it's going to gray that box out, and now we're in auto mode. So we're going to watch the fleet ramp up to the design rate. We just staged automatically to a 40 barrel a minute stage. We see the set point there is 40 barrels a minute, and Octiv is grabbing rate. So it's controlling the whole fleet to the customer's design.
Yeah, and you can see all the
pumps moving over there.
Pumps going up. Yeah,
that's exactly right.
Impressive. So that was the operator preset, basically, was what that little icon was, right?
That's right.
Hey, do what the operator wants, boom.
That's right. So we're always just one click away from manual operations. It's kind of like cruise control in a car. Tap the brakes and you're back in control. So we still have that same element here when we're running an AutoFrac.
So if I clicked on that again, then it'd be back to me, and I could.
That's exactly right.
Okay.
And running an auto can be a little boring. So in fact, if you want to have a little fun, click on that again. We can come up to 50 barrels a minute, so you can go up a couple more clicks.
There we go.
Grab a little bit more rate. So we see it's really just, it's like running playing a computer or video game. Whatever you put in that box is what the fleet's going to do for you.
Right.
So if you'll drop us down to 20 barrels a minute, we're going to show these pumps off a little bit now.
There we go. Load balancing the spread gives a little.
That's right.
Hey, I'm bringing everything down.
So let's play a scenario out here. Let's say that we have a pump that has an issue. So we would see a notification pop up. We would see that pump light up there.
Or it'd be like flashing red or
that's
something.
Right. Yeah. We could click on it. So if you'll click on pump 745 there, and then on the far right side of the screen, there's a you can see that bottom right quadrant.
Oh, yeah.
Is our pump control window for that pump. If you'll click on the far right of that on the health report button.
Which one is that?
Further right and a little higher.
This one.
That's it right there.
There we go. Oh my goodness.
Now we can come in and we can come in and actually look at that unit. We can monitor for any errors, see any variables that are highlighted that we need to go in and for some reason or another take that pump offline.
Oh wow!
So
all of this is real time information being fed back in. Yeah,
that's right.
Wow.
So we'll pretend something's wrong with that unit and we have to take it offline. So if you can X out of this window. Now, before Octiv, you would need to decide which pump am I going to get more rate from.
Yeah, you'd have to adjust
pump.
it. Yeah, exactly.
In this case, in that pump control window on the far left, there's an assignments drop down. Just below that to the left, where it says dirty.
Oh yeah, I gotcha.
Yep. If you'll click offline. So all we're saying here is
take that one offline.
Take that offline. So Octiv gives it a rate set point of 0. It grabs rate from the other pump, so it's load balancing the spread. And if we look at our speedometer here, we're still pumping at 20 barrels a minute.
Yeah, that's crazy. I mean, there was no dip.
That's right.
We took a whole, quarter of the pumping apparatus offline, and there was no dip. I mean, it stayed consistent. Yeah.
That's right. So we've separated how we control the fleet and the equipment here from how we control to the customer's job design. So the customers, they don't want to have to worry about when we lose a pump, what happens to the well. Their well has no idea that we just took 5,000 horsepower offline.
Right.
All they see is 20 barrels a minute.
And that's the automation. That's the genius of using computers and all of that, because it can, instead of just, okay, we're taking that one offline, shut it down, it must bring it down slowly while it brings the others up to keep the rate consistent.
That's right.
Yeah.
So it has to solve that problem of what rate do I need from each pump? What slope should I control the pumps to achieve that?
And what if there was something catastrophic, like it wasn't us intentionally taking it offline, some just happened, it'll still make that adjustment?
That's right. So Octiv, we have a lot of unit health protections that run monitoring the pumps. And if something happens, Octiv will first alert you. And then if it has to, it'll actually take that pump offline for you and still load balance the spread.
Wow.
So making the role of even just monitoring the fleet easier and automating those responses to keep the units healthy.
That's crazy.
Now, a problem with what just happened, these Zeus pumps, they're 5,000 horsepower. That's a lot of horsepower to take off in the middle of the stage.
Right.
So, we'd like to find a way to reduce that. So what our Zeus equipment team has done is built a decoupling mechanism where we can take just half of a pump offline and use the other half.
Yeah, because you got two 25s on those, right?
That's exactly right. Two fluid ends, and they can be decoupled. So to start, if you'll go back to that assignment on 745 and change it back to dirty. So we'll bring that pump back online. Let's say nothing was wrong with it after all. And then you can now pick pump 739 in the top left, and we're going to actually decouple a fluid end on that. So on the bottom right, you see there's two fluid ends, front and rear. If you'll click on front fluid end,
is that this one?
That couple button right there.
Are you sure you want to do that?
I'm sure. If you are.
There we go.
And now what you can watch, we've got a camera that's backed up against the power end of that.
Oh, yeah, right there.
We're looking down the drive line towards the electric motor up at the top. So Octiv is going to bring rate down on that pump. It has a rate set point of 2 barrels a minute now. And if you watch this camera feed, you're going to see those arms at the very top, those two black pucks extend down and knock this fluid end loose. So we'll give it just a minute and see the action.
That's crazy.
And there it is.
Yeah, wow.
You can still see the drive shaft moving.
Yeah. The drive shaft's still going, but it's not attached anymore. That's for sure.
If you look at that screen in the top right, you can see the hoses turning on the fluid end on the right, but they're still on the one on the left. So that pump's still out there. It's still giving us the 2 barrels a minute, but that other fluid end is offline now.
That is amazing.
So now that that's done, Octiv has already alerted us, bringing pump 739 online with front fluid end decoupled, load balancing the spread, and now we see Octiv is giving that pump a new rate set point. So it's keeping us at 20 barrels a minute. And check out this line here the whole time.
Yeah,
we just stayed at 20 barrels a minute the whole way through.
That's insane. That is really, really amazing. I mean, because this is something that would have caused downtime before, right? If you had to take something.
That's right.
Yeah. So now this is fantastic. And so you were saying that every fleet now has this level of control, or are there just certain ones that have the?
Yeah, all of our fleets are running Octiv here.
Right.
The auto frac service is launching this summer, so our first crews are going to be running. But all of them have the capability for it.
Oh, okay. So it's just a plug and play.
It's a plug and play thing. It's a training and going out and deploying the service, training the customer. You mentioned earlier, the company man's role. It's a little bit different with this. They don't have to make decisions about screen outs or how fast they want to go. They can focus on job execution, keeping people safe, coordinating across vendors, and kind of let the control system do all that.
Yeah. No, that's a super impressive system. So how do we shut it all down? How do we safe?
If you'll just come in here and type a 0 or click those down arrows, bring us down to 0. Those pumps.
What was that noise?
Yeah, those are the brakes on these pumps. So
so it doesn't just let them spin down; it actually slows them down.
It brings them down in a controlled manner. With a diesel pump, you've got a transmission. You can just disengage. These don't have a transmission on them, so we actually have that braking mechanism, so we can stop it as quickly as we need to. And the last thing you'll do is hit the stop button there. That'll take us out of the stage, and that's all there is to it.
Oh, my goodness. Well, I'll tell you what, this has been an exceptional demonstration, my first frac job. So
congratulations. You passed Halliburton's pump operator training program. We'll give you a certificate outside.
I'll be looking for a job.
Perfect.
But thanks so much, Eli. This is really amazing to see this technology firsthand, and really to see how, this type of automation has just made all of the operations, the pumping operations, so much more efficient. I mean, it's crazy. I just can't even imagine. I mean, do you have on the top of your head like an overall time savings number, that you guys like to throw around?
Well, that's a good question. I'll talk about the health of our equipment because that's really important. Some of our major components are lasting 25% longer now since
25%. Wow.
That means 25% less times that somebody has to go into the red zone, work on a pump, 25% less times that pumps have to round trip to a yard for an engine repair, a transmission repair. So we've seen a huge benefit. Our crews are pumping more hours now than ever before. So
that's fantastic. That's not only good for you and your equipment, good for your customers.
That's exactly right.
Exactly. So thanks again for being on the show. Appreciate it.
Thank y'all for coming out to this.
Hey, everybody. We're in Duncan, Oklahoma at the birthplace of Halliburton. And Halliburton is giving us a little peek under the skirt, right, Kurt?
Absolutely.
And so first up today, we have Kurt Harpold from Halliburton.
Yep.
Kurt, welcome to the show.
Well, thank you very much. Appreciate having me.
Yeah, fantastic. So I always like to start out by, kind of telling everybody a little bit about yourself, your position, how you got to this position, that type of stuff. So give us a little bio.
Sure. Well, I actually started at Halliburton a little over 18 years ago, and mechanical engineering degree, and then Halliburton picked me up as an engineer, and I've bounced around to a variety of operational engineering, technical roles, sales roles throughout my time here. And currently, I'm the strategic business manager.
Okay.
Over fracturing operations.
That sounds important.
Yeah, we're always trying to look at, what's coming next, right? 2 to 5 years out in the future. Where do we want to go?
Wow. So you're like the oracle. Like when we're talking to you, we're going to finish up with that. We're going to ask you what's cooking in the kitchen. So Kurt, tell us what we're standing in front of here.
Yes. So this is our Express Connect valve skid. Okay. This is our latest iteration of our iron management system. And essentially, if you go to a location, especially just a few years ago, you typically have a lot of lines on location.
Yeah.
There would be iron everywhere, right?
Right.
Well, most of the industry has made a transition to 7-inch, go to monobore single lines.
Right.
And we have as well. So over the past 6-8 months, we've been focused on getting all of our North American land crews transition to 7-inch lines. Now, the crazy thing is, even with all that change taking place, we still send people into the red zone, the most critical and dangerous area on location, right?
Right.
To relieve pressure by hand.
That's crazy.
Yeah. Unbelievable, right? So all this technology and advancement, and yet we're still doing that. So how do we get people out of the red zone? So we put a concerted effort focused on how do we go to a people-free red zone, and not just being able to, remotely bleed things off, but how do we integrate it into our work methods? How do we integrate it into our standard work?
Right.
So that's exactly what you see here. Over the past 6 months to a year, we've focused on getting this valve skid without the controls and everything on it in place on all of our crews in North America. And now, from now to the end of the year, it's going to become standard where we actually go out, implement all the controls, all the functionality and features and automate those skids.
Wait, so you can retrofit this on the skids that are already in the field?
Absolutely.
Oh, that's awesome.
Yep.
That's awesome.
That was the key, getting all the base hardware out there first, and then we can come back, put the controls, the accumulator, the control, or the actuators on everything later.
So tell us about that. Tell us about how all of this together will keep people out of the red zone, and nobody's going to have to come up and bleed off crazy pressures. Right?
Sure. So again, today, the people will go in the red zone and they'll bleed off these valves by hand. These are typical low torque valves, and we've gone back and we've put hydraulic actuators on all of them, right? We've also integrated control stand, a hydraulic accumulator, which is electric powered. So it plugs in, especially all of our electric fleets, any of our diesel fleets too. We can plug it right into the power source on location and power that accumulator.
Okay. And so all of this is controlled like on site, like we can't see it from this side, but on the other side, there's a control panel. Somebody has to do that, or is that jacked into something where somebody's far away from this?
Yeah, this whole control panel is completely enclosed on location, and it all feeds back to our data van. We control it through what we call Octiv Surface.
Mm-hmm.
So Octiv, our intelligent fracturing platform, we've taken it to the next level. We're incorporating Octiv Surface. So what you can see on the screen here behind you is actually some of our layouts in the data van and some of our software that we'll be utilizing. That way we can control everything from the data van, understand the flow paths, what pressure's on the lines, and when we want to bleed off, we can bleed down to whatever pressure we want to move right into the next stage. And the beauty of this is not only does it allow us for people-free red zone, we can get to the point where we integrate it with wellhead companies and we go to a continuous pumping on all of our crews.
Wow, that is impressive. Now, I can't help but think, because like I know just a little tiny bit about oil field electrification, and I find it odd that you chose hydraulics over electric actuators, because it seems like, you know, especially in the offshore world, they're replacing a lot of the hydraulics with electric these days. So why the choice to use hydraulics?
So in this case, you know, obviously moving to electric has a lot of benefits, but the hydraulic actuator has been tried and true and proven in the industry for many years. Right? We've been using the exact same actuators for over 40 years in different applications. Mm-hmm. So what we've done is we've powered it with an electric over hydraulic system. It keeps the hydraulics very small, and it allows you to have stored energy. So even in the event you would lose power, you would have some stored energy through the accumulator system where we can still actuate these valves.
Okay, yeah. That's
it also
important.
keeps everything compact, right? Most electric actuators are a little bit larger, and especially with this prime up bleed off manifold the way we have it, we wanted to keep it small and compact on location.
Yeah, because with electric actuators, you probably couldn't fit them in that same configuration.
So we actually looked at them. There's about 3 to 4 times these size for most of them on the market.
Yeah. And so, you know, in your role where you're thinking about these things, I'm always fascinated about the process that something comes to this, you know, that new product is developed. Mm-hmm. So in this, how long have you been thinking about this? I mean, how long does it take for, like, you know what, we should just set it up so that we can get everybody out of the red zone, and let's get to work on that. To now we're looking at it. How long does that take?
Yeah, so typically from ideation to commercialization, most things take about a year. Okay, depending on the complexity and what it is, right? Yeah. So something like our Zeus pumps or blending, those might take a little bit longer, larger project. But something that's a little bit smaller, simplistic, under a year typically.
Yeah, and so now this is going to be the standard going forward. Like if somebody had a new fleet out, this is coming with it, with all the actuators, everything all set up.
That is correct. Actually, so over the next, by the end of the year, our plan is to make this standard on all of our fleets, whether it's electric or diesel.
But like the new ones, like, so you're going out and retrofitting things
Correct.
that are out in the field.
Yep.
And then, but any new ones that roll out now, they're like this.
Yeah, they will roll out with this.
This one's getting ready to roll out, isn't it?
Correct. Actually, like I said, this one is going to be rolling out within the next month or so.
Wow. That's impressive. Well, Kurt, thanks so much for taking the time. Hey, before we let the folks go, I got to ask you, man, because of your role with the company. So it took you a year to get this developed, get it all worked out, and to get it out in the field. But since you're looking forward into the future of what's coming up, what's something that you're excited about that you can tell us about? I know you can't tell us about everything, but
right.
so give us a little peek into the future of frac.
So, we're one of the last few that actually design, manufacture, deploy, maintain, operate our own equipment.
Right.
Make that design loop pretty quick. So we're always looking at our electric pumps, the backbone of the frac fleet.
Right.
So we got some pretty cool stuff coming out with some of our pumps, a couple more iterations. And the biggest thing right now is we're actually taking our pump, which is a true 5,000 horsepower.
Right.
We're going to be making it 6,000 horsepower.
Really?
Yep.
Really? That's interesting to me because in the pump world, I guess the 5,000s are catching on, but it seems like most everybody's using still like 25s, right?
Yeah. I mean, most of your diesel or your dual fuel is 2,500, right?
Right.
So electric affords you that power density, and we're taking it to the next level.
That's crazy. Well, Kirk, thanks so much for being on the show. And
thank you very much.
Thanks for showing us the equipment.
All right, appreciate it. Have a good one.
Thanks for tuning into this special series of World Oil Deep Dive, your go-to source for the latest technology in the energy industry. We hope you enjoyed today's episode and gained valuable insights to help drive your business forward. Be sure to subscribe so you never miss an episode, and follow us on our social media channels for more updates and industry news. Feel free to reach out if you have any questions or topics you'd like us to cover. Until next time, keep innovating and stay ahead in the energy sector with the World Oil Deep Dive Podcast.